Hi, I'm Doug Black with Inside HPC, and today we're speaking with composable infrastructure company Liqid. We have two senior managers at the company, Eric Oberhofer. He is Vice President of Public Sector Sales, and Matt Demas. He is Vice President of Advanced Computing. And Matt, let's start with you. Explain what Liqid does and why it's important.
Yeah, sure. Thanks, Doug. I appreciate your time. So Liqid is very unique in that when you look at HPC today and you look and you say, I have to deal with a whole bunch of static infrastructure. I have to plan ahead years in advance because I want my hardware to meet tomorrow's challenges, right? What Liqid does is it allows us to really kind of disaggregate all of those pieces of hardware. And when we do that, it allows us to dynamically recreate a hardware based on what the software needs it to be. So if for one workload it needs to look like one thing, and then the next workload 10 minutes later it needs to look different, we can dynamically reconfigure that hardware. So it makes it very similar to a software-defined hardware approach.
Interesting. Eric, let's turn to you. Liqid has recently won contracts with the Department of Defense for HPC deployments at facilities in Maryland and Mississippi. Tell us about those deals.
Yeah, Doug, thanks for having us on. Really appreciate it. So those were very exciting wins and opportunities for Liqid as a company, and kind of showing that composable infrastructure is not only prime time, but ready for rack scale, multi-rack deployments. The opportunities that we won were actually to build and operate and maintain 3 of the supercomputers for the Department of Defense's high performance computing modernization program. So once again, very exciting for us in introducing composable dynamic infrastructure at scale. And so across those 3 systems, we are looking at north of 200,000 Intel cores from a compute perspective. We've got 30 petabytes of usable all NVMe composable storage in a parallel file system. We're using 900 or just over 900 NVIDIA A100 Tensor Core GPUs. And all this is connected together using Mellanox's HDR200 networking InfiniBand. So once again, we're very excited being able to rapidly and dynamically reconfigure the hardware stacks and based off of what the workload requirements are, kind of fitting a hardware profile on the fly for the software that's running and the workloads that is running. That's what we're enabling the government and the Department of Defense to do. It's a rapid shift from kind of the static architectures of traditional HPC, where you had different types of nodes that did not have the ability to change or accommodate different types of workloads.
Okay, thanks, Eric. Matt, how is Liqid's ability to reconfigure data center resources on an on-demand basis? How is that key to these deployments?
Yeah, thank you for that. So what's kind of how HPCMP and many other HPC programs work is they have these static infrastructures that are built years in advance, like I said earlier, but their challenges are always changing, right? So you're always in an environment where you never know what tomorrow's challenge is going to bring. Look at COVID and what that's brought to a lot of these HPC centers trying to go solve these challenges. Well, in DoD, that's even more of the case, right? You have all these branches of inside the DoD that have new research and development projects. They have soldiers where their lives may be in danger. They need a problem analyzed and solved. So you never know what tomorrow's challenges are going to bring. It's an ever-changing environment or ecosystem within the global economy, the global environment. So they have to be able to be prepared for whatever challenge tomorrow brings. So when they looked at Liqid, they said, hey, you know what? We now have this new capability where I can buy this base level of infrastructure, but if tomorrow I need to have an environment where I have 2 A100s in a whole bunch of boxes, or I need to have 20 A100s in a much smaller subset of boxes. These different types of resource allocations could really help improve time to value, right? Or how fast I get a result, how effective that result is, it also allows them to be more of a heterogeneous computing environment. So there's so many advantages to having this flexible hardware. By allowing them to let their software kind of define what that hardware needs to look like, it puts them in a scenario where they don't have to go change their software. They don't have to go change their algorithms to go meet what they bought 3 years ago. Instead, they say, hey, you know what? This works the best for me. This is going to be the best result. So let me go ahead and re-outfit my hardware to go match exactly what I need. And that's from an accelerator perspective. That's from a memory perspective, even from a networking and disk perspective. All of these things can be reprogrammed to give them exactly the resources they need for the most effective result.
Thanks, Matt. And really impressive stuff. Eric, back to you. Can we expect more solutions like Liqid's move into public sector HPC in the future?
Yeah, I mean, not only with moving into the public sector and all of the the state financed and state sponsored types of rack scale supercomputing, but also just looking at the applications of and interest in AI and machine learning. What we believe at Liqid is the power of composability is going to kind of change the way that data centers and data processing is done going forward. Liqid's unique approach of being able to kind of the power is in the fabric of itself. So we compose resources over a PCIe fabric. We also have the ability to do it over high-speed Ethernet and InfiniBand. So what that enables us to do is say we start looking at resources as global resources that we pull outside of a traditional server chassis and pool them. And on the fly, researchers in the HPC environment or end users are able to say, hey, I've got this workload and it requires X amount of hardware resources, go build it for me. And so, what we're seeing now is a large uptick on kind of changing the way the HPC is being done, how AI is being done. AI is a workflow. It's not a product. It's not something that just happens. So being able to dynamically compose through the different phases of the workflow process for AI, it enables more flexibility as well as just higher resource utilization of these new types of accelerators. As Matt had mentioned, we see at Liqid that heterogeneous computing is going to kind of be the future where everything is looked at as a resource. So being able to compose against x86 or ARM-based servers, different types of GPUs or other hardware accelerators, different types of NICs and smart NICs and DPUs, and even composable memory and composable NVMe. Being able to move all of those types of resources around is really going to change the game on how HPC is done in the future. And the last thing I do want to mention is, one thing that we're going to see coming from Liqid and just in general is being able to do more kind of AI, HPC, and composable at the edge. Very dense, very small form factors, space, weight, and power constrained, but still being able to introduce different types of accelerators, being able to capture data, ingest data, manipulate the data, and kind of do in-the-field analytics using different types of hardware accelerators.
Okay, sticking with you, Eric. So the deals we've talked about those are government computing deployments. Now, do you think composability will also work its way into enterprise HPC?
Oh, absolutely. I mean, we're already starting to see it. We're getting a lot of interest. We've got great partnerships with NVIDIA, and we're seeing a lot of customers just seeing the value of using different hardware accelerators. The Ampere technology with the new GPUs, being able to kind of take code sets off of traditional x86, remodify the codes, and port it over to using general purpose GPUs, and getting such a bigger bang for their buck. From the enterprise side of things, if you're able to show return on investment, much faster, time to market much faster, it's kind of a no-brainer. So we're seeing a lot of interest from our enterprise customers already.
Okay, well, Eric, Matt, thanks so much for that update on Liqid.
Awesome. Appreciate it.